Welcome back, slot car fans. We're here to share with you some more things that you might want to consider when designing your slot car track. If you haven't seen our first video on track design considerations, you can get it here. Also, the link is in the description. Just to note, like our first video on track design considerations, much of the information here is geared towards Carrera Digital. However, some topics may apply to other manufacturers of digital slot car sets and analog tracks as well. Although not a design element per se, track planning software is a great help when designing your layout. Unless you just have a small amount of track that can only be set up in a few simple configurations, track planning software is going to be a big time saver as opposed to just starting out building with only a rough idea, or even worse, just making it up as you go along. If you start building without a solid plan, what can happen there is you get about halfway through and realize you don't have the right track pieces remaining to finish the track as you had imagined it. So then you find yourself putting in whatever random pieces you have left to get the circuit to connect, and you end up with a big section of discontinuous garbage that doesn't flow and doesn't make any sense. Or you start running out of room because the track is turning out to take up more space than what you had imagined. Or you get towards the end and realize the track won't come together correctly because it's about 2 inches off, so you end up rearranging one part of the track a bunch of times to try to make it come together right. Or maybe you get the whole thing complete, stand up, take a look, and then realize that the layout is dumb. We use a program called Ultimate Racer 3.0. It includes track libraries for all the major manufacturers and also some I've never heard of before. But you've got the Scalextric, you got Ninco, Carrera 132, as well as the 143, and even HO scale like AFX and Tyco. In the software, you can input your stock. At least with this one, I'm sure others have the same capabilities. So for example, how many standard straights you have, how many radius 1 turns you have, lane changers, and so forth. And as you add them to your design, it tells you how many you've used, how many you have left of each piece. It can also help with your spatial analysis, for lack of a better term. For example, here we're trying to fit this track on a 6 by 12 foot table. And sitting this way, we find out it's a little bit too big. It's hanging over the edges slightly. So we rotate this a few degrees and find out that it fits much better in this orientation. And that's always good to find out before you start building the track as opposed to having to reorient it after it's all together. Also, you can look at the properties of your track when it's finished or even when it's partially finished. This here shows the length of each lane, how many degrees of left turn and right turns you have, important if you're trying to get your lanes balanced. Also, there's the grid. This one is set to feet, but you can set it to other units of measure. This is important so you know how much space the track's going to take up. So track planning software is absolutely fantastic to use to plan your layout before just starting to build at random. Do yourself a favor and get some quarter straights and third straights. You're going to need those to complete your circuit most of the time. Unless you have a track that uses all the same radius turns or it's completely symmetrical, chances are you're going to need something other than a standard straight section of track to get the circuit to connect. So for example here, to complete this, we'll put a regular straight in, and then what's left is definitely not enough room for a full straight, so that's where the third or quarter straights come into play. Sometimes you'll need to use these in conjunction with each other when your gap to fill is, say, 2/3 or 5/6 of a standard straight. I'd say with all the tracks we've built, we've probably used just about every one of these combinations. Sometimes you'll get a situation where the gap is smaller than even a quarter straight. And the track is somewhat flexible, so sometimes you can get away with having to nudge it over a quarter or a half inch or so to get it to connect. If the gap is too big though and you try to fudge it, you can end up compromising the joints, where you end up with a little bit of a gap between two pieces and then a little bit of a gap between two other ones, and eventually that starts to affect your conductivity. And if you end up with gaps on the turn sections of track, that can start to affect the handling of the car in that turn too. Because of their geometry, the bank turns allow you a little bit more flexibility without compromising the joints. You do have to be careful though how much you flex these bank turns, because if you go too far you will end up with kinks at the joints. So if you expand the radius out too far, you're going to end up with high spots everywhere that two pieces of track meet, and that's definitely going to affect the handling of the car. And conversely, if you squeeze this in a little bit too much, you're going to end up with low spots at every joint in the track, and that will also affect the handling of the car. However, this topic is not about bank turns, but the next topic is. We're big fans of the bank turn. They provide some variety to your layout. You can carry more speed through them than a standard flat turn, allowing for a faster track. And if you saw our first video on design considerations, they're good to put in places that your track isn't too accessible, therefore minimizing the need to marshal cars in difficult to reach areas. There are some caveats, however. When integrating a bank turn, note that they require two straight pieces of track to transition back to flat. So if you have limited space, keep in mind that the assembly takes up the size of the turn plus the transition, and you can start running out of real estate pretty quickly. Also, you don't want to use a lane changer as your transition track. We've gotten away with having only one standard straight off of a bank before having a lane changer, and that was really pushing it. But definitely, you don't want to have it directly after the bank because it's going to twist, and that could bind up the mechanism in here. Also, these tracks have electronics embedded, and you don't want to risk breaking the PCB side, the printed circuit board inside either. And that's not just limited to lane changers, but any sensored tracks such as the entrance to pit lane or the control unit as well. When considering getting a bank turn, you need to remember what cars you're planning on running on your track. The bank turns are somewhat of a dish. They're concave, so it's like driving in a bowl. And the smaller radius turn, the more pronounced that curvature is. So, depending on the car, it may not work too well. This one here is a DTM, and they have these aerodynamic strakes on the back. And on a number 2 bank, these strakes will hit the track and cause a loss of lateral traction, forward traction, all sorts of traction. Although Carrera states right on the package for this car that the only restriction is the number 1 bank, we find we have to grind these strakes down a little bit to make it run on a number 2 bank. Most cars stock though don't have a problem with the number 2 bank, and pretty much everything will run on a number 3 or number 4 bank. But unless you're planning on running nothing but 1940s Willis Coupes or other cars with a ton of clearance on the front and back, forget about trying to use a number 1 bank. One last thing, and this is our experience with Carrera, but other manufacturers may be the same. If you're running a car stock with the magnets, you can go slow around or even stop on the turn and restart. However, if you like to run the car with no magnets, you do have to carry some decent speed around the turn. If you go too slowly, the back end of the car can actually start to slide down the bank. And if you happen to stop the car on the bank, forget about getting it going again. Carrera race sets come with only the radius 1 turns, and these rad 1 turns are the sharpest turns. And while these are the most compact, it also means that they're also the slowest turns. And so to make your layout a little more interesting and add some variety, you can add different radius turns. The radius 2 turns being a little bit more gradual than the radius 1, and then the radius 3 more gradual than the rad 2, and then the largest radius turn being the 4. So having an assortment of radii of turn, you can have a much more interesting layout, more fun, and it requires more skill as each of these turns has a different maximum speed that they can be taken at. And as originally developed, these turns were made to nest with each other, as their origin is in analog racing where you might have a 4, 6, or an 8 lane track. With digital, you don't need a 6 or an 8 lane track, although you could, but 4 lane tracks aren't uncommon in digital though either. Even if you're only running a 2 lane digital track, you can still nest these turns like in these examples here. This track is on the floor and people need to be able to walk around here, and so nesting the turns maximizes our infield area. So even though it looks like a 4 lane track, it's actually 2 lanes going one direction, 2 lanes coming back in the other direction. And all of these tracks come in a high bank variety as well. As mentioned in the section on bank turns though, be aware of the radius 1 and 2 bank turns, as some cars will have trouble with those. If this video helped you out, be sure to give us a like. Keep an eye out for more videos, have fun, and we'll see you next time.